Hello, assalamu alaikum. Hello, hello, can you hear me?
Hello, assalamu alaikum,
Wa
brother.
alaikum assalam. Okay, so how are you?
Ramadan Mubarak. I'm fine.
Yeah, Ramadan Mubarak.
I use
Okay,
another I use another username in Google Meet. AM.
okay, there is no problem, no problem.
Thank you very much.
Okay, so now we'll start our today's online training program. So basically, today is our fourth number of online training class. We already taken the first, second, and third day, and today is our fourth number of class. So let's go over today's class. Okay, so I also try to record a video class. We also get the recorded video class. Okay, so I simply start the recording. Okay, so now can you see my screen?
Yes, it's easier for me. Thank you very much.
Okay, then. Okay, so hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis from beginners to advanced level. So we already covered our first day and second day, and today is our fourth number of class. So first of all, I will try to discuss our full course content. So these are full course content. We try to complete all of the things within 7 days. And today is our fourth number of class. So basically today I will try to discuss about that how you can easily remove cloud from your satellite images. So mainly when you want to work for the rainy season image or as well as also dry season image, then you can also get some cloud on your satellite images. In Google Earth Engine platform, we can easily remove all of the cloud and haze from the satellite images, and we can get the very clear satellite images. Okay. And secondly, we also try to discuss about that how you can easily use the DEM data or digital elevation model data and created the hillshade map, salt map, and aspect map in Google Earth Engine using the NASA SRTM DEM data. So basically, there are the lot of different source for we can get the DEM data. And the same process in this time, I used here the NASA SRTM dataset. And then we also try to discuss about the land surface temperature monitoring from MODIS satellite imagery and making the time series chart. Okay, then how to calculate average, maximum, minimum NDVI for any specific region. Okay, so this is a full course for 4 day course content. We try to complete all of the things step by step. So how to remove the cloud from satellite images, how can easily visualize the dam of hillshade map and solve map asset map in Google Earth Engine. Then how can easily monitor the land surface temperature and how to calculate average, maximum, minimum NDVI for any specific region. And first of all, visualize the DEM data. So there's a lot of source in the DEM. We can use at the NASA SRTM in this time. Okay, so and also try to show you that how can easily make this type of map, elevation map or aspect map, solve map. Okay, so let's go our code editor. So just I simply open a new code editor in my browser. Okay, what happened? Just a minute. So open a new code editor. Okay. Just check what's the problem for opening code editor. Okay, now we can check again. So I think some verification also there in this time they are also added. So that's why first time it not open. But when I want to verify all of the things, now this code editor will be open. Okay, okay, okay. So now I can get this code editor in here, and now I want to use this code editor and then try to show you that how can easily work with the NASA SRTM dataset. So just I simply search here dataset NASA SRTM. So now I can say I can get the dataset NASA SRTM digital elevation data. So basically this dataset is that resolution is a 30-meter resolution. Okay, and we can get all of the information about this dataset, how it will be collect the data, and also you can get the band. So mainly is the one band you can see elevation, and this resolution 30-meter, and this elevation unit is the meter. Okay, in this time I simply import the data set. So I simply import, you can see now this NASA SRTM digital elevation 30-meter resolution data set is imported, and it's the image, it's a variable name of this data set. So mainly my full image collection is stored in this variable image. Okay, so now I want to display the result. Just simply use at the map dot add layer and call the image. Okay, and click to the run. So now you can see it added a elevation map or elevation data for the whole world. We can get the data for the whole world. Basically, this is the global data set. In this data set, we did not understand about that where the high and low land. We did not understand. Okay. So in this time, I want to add here the some visualization. Suppose I want to show the visualization mean, it will be start from the 0 meter and max up to suppose put the 30 meter, 300 meter, then click to the run. So now I can get the some visualization, and I can easily identify where the high and low land. You can see in this time we can get the two type of color, white color and black color. So this white color is identify the high land, and this black color is identify the low land. So I simply click on here. You can see what is this elevation. You can see 4,842 meter, and when I want to put on the black color, you can see I can get the only for the 11 meter. So in this time we can get the map for the whole world elevation map, and in this time the white color identify the high elevation and black color identify the low elevation. Okay, so in this time I also add here the some visualization, such as I also add here some color plated. Suppose I put here the plated, such as I make a list. Suppose I want to show the blue color, then yellow color, and high level I want to show that suppose red color and click to the run. So now I can get the result look like this, you can see. Okay, so in this time we can get the three type of color. So here you can see the red color, it's identify the high elevation, and yellow is identify the middle, and blue is the lowest. Okay, so when I click on here, you can see I can get the result. When I can get the result look like this. Okay, when I click on here, I can get the look like low elevation. Okay, so in this time I want to need this data for any specific region. Suppose I want to need this result for any specific region, then I can easily import it my shapefile and work with this. And before that, I want to work for the globally, then I also use my own boundary shapefile. Okay, so let's go. So in this time, I can get the DEM data. So this is the DEM data. Okay, this DEM data now I want to use and make the hillshade map so that I can easily identify the hillshade. Okay, so let's go for hillshade map. I take a variable, suppose hill shade. You can use any variable name, there is no problem, and use a function art engine train dot hill shade. Okay, this is the function. Okay, so basically this is the function. This function create the hillshade map, and you need to input here the data. Okay, so input in this time this image, because I use this image and then try to make this hillshade map. Okay, it's not it, I simply remove, it's not it. Okay, so now display the result. So I simply use at the map dot add layer and call this hill shade and click run. So now I can get the hillshade map, you can see. Okay, so in this time, this hillshade map is not meaningful because we did not identify the hillshade area. So in this time, I also define here the some elevation. So I put here this, suppose mean. I put the value, suppose 150 meter, and max such as 280 meter. Okay, and then display the result. Then we can easily identify in this range all of the hillshade, and we can also get the 3D view. From this, we can easily identify. You can see. So in this time, we can get this. You can see this is the hillshade. We can easily identify also this hill. Okay, so in this time, when I want to just decrease the level, okay, then we can also get the better idea about this hillshade. So I also zoom in. So now we can get this better view. Now I can see this is the hilly region. You can easily identify this is the hillshade. I also zoom in here. So these are DEM data. Okay, when I want to apply here this train function, then you can easily identify this is the hillshade, also hill. Okay, we can easily identify the hilly region. Okay, so now I want to put here the suppose I want to calculate make the map for suppose solve map. Okay, so this is the hillshade. I put the layer name, suppose hillshade. Then also work for the another thing for solve. Take a variable, suppose solve, and put the same function art engine train, and use at the solve this function. Then put the input image. Okay, and then display the result. Suppose put here the map dot add layer and call this variable name solve, and put here this suppose mean. Suppose put here the 0 degree and max up to suppose 30 degree. I put this in this range, and put here this, suppose this is a solve map, and click run. So now it also display the solve map. So we can get the 3 layer, you can see. and this data we can get for the whole world or global. Then we can easily use our boundary shape file, which array I want to need, and we can easily clip. Okay. So now you can see we can get the data set. So first of all, this is a solve, and this is the Hillshade, and this is a dem. Okay, basically this is the dem data, NASA SRTM dem data, and from this dem data we can just create this Hillshade. This type of Hillshade we can create. Okay, we can easily identify the hilly region from this data, and okay, where the high solve, where the low solve, we can easily identify from here. And not only for the solve map, if you want, you can also create the aspect map. So you can say I can simply put here the aspect, such as use take another variable. Suppose this variable name is that aspect, and use at the art engine train, and use at the aspect, and call the data, such as data is the image. Okay, and now display the result. Suppose map dot add layer, and call this aspect, and click on the run. So now I can also get the aspect map. You can see another layer is also added in here. So now we can get the result for Golo Valley, aspect map, solve map, hillshade map, and also get the dem data. So now you can easily export all of the images from here, all of for a specific region, and then you can also make the further analysis for the using the ArcMap software or QGIS software. Okay, so different analysis we can easily do from here. So this is the aspect map you can see. Okay, or global data set I can get. So in this time, I want to work for any specific region, and from this region, I want to export all of the data, all of the map, such as solve map, aspect map, hillshade map, and work with this. Okay, so let's go. So for that, in this time, suppose I want to work with a specific region. So previous class we also tried to discuss about that how you can easily import your boundary shape file. Suppose in this time, I want to work for a specific region of Bangladesh. Okay, so I want to work for this. Suppose I want to work for this Bangladesh district, a specific district, and then try to show you that how we can easily export this map for hillshade map, solve map, aspect map. So you can see here I had already imported all of this country boundary, district boundary of Bangladesh. Okay, and you can see in this attribute table in here. So this attribute table name 2 has include all of this district name in here. Okay, so in this time I want to import this. So just I simply import data set is imported this district boundary. So now I want to display my specific region which I want to work. So I simply use at the var. Suppose I put this variable name, suppose ROI, and then call the table and use at the filter. How I can filter Earth Engine filter, then equal. What's equal what? I simply call the name to. Suppose in this time I want to work for this region such as district. So I want to work for this district. Okay, so I also try to find out the all of the name. So simply use the print function and call the table, because this variable stored all of this district name. Okay, so just simply print this table and click the run. So now you can see we can get all of this district boundary name in this here, and from this which district I want to need, I just simply copy this name and work with this. Total 64 district we can get in here. Suppose we can check the name. Okay, so you can see name to Parvatto Chattogram. So I want to work with this district, so I simply copy. and paste in here. Okay, so now I display the result. So simply use the map dot add layer and call this ROI and click to the run. So now it display this our boundary area, you can see. Okay, it loaded. Okay, so this is the region. You can see I can get this region in here. So this is the region. Okay, so if you want, suppose in this time I don't need the result for okay chart program division. So for that I can simply go to in here again, and then simply you can see go to the properties. In this properties you can see the name one. Okay, basically this name one is including the division. Okay, so just I simply use here the name one and call this Itagong. Simply copy and paste and click to the run. So now I can get the result. You can see for the boundary of the Chittagong division in here. Suppose this is my full region of interest. So for design, or we can use the same way. Suppose I want to use that the same only for the Parvotto Chattogram district. It also better, okay? Because in this district in Bangladesh, only for this district we can get the some hilly region.